Let's begin Chapter 19, Amino Acids and Proteins, by looking at the general structure and classification of amino acids. Okay? So, we often think of amino acids as the building blocks of proteins. Okay? That these amino acids, they link together and build all the proteins in the body. Well, amino acids, so to say, they have a similar structure. Okay, so amino acids, what we look at is we have a carbon here in the center. Okay, and it's often called the alpha carbon. Okay, the alpha carbon. Now, on that carbon, there are four bonded groups. First, there's just a hydrogen. Okay, a simple hydrogen bonded to the alpha carbon. Then you have an ammonium group. Okay, an ammonium group. Okay, look for the nitrogen. Okay. So we have this ammonium group with a positive charge. Then we have a carboxylate group. Okay, a carboxylate group. Now that carboxylate group consists of the carbon with a double bonded O, okay, what we call a carbonyl, and then the oxygen single bonded. So this carboxylate group is a carbonyl group with a single bonded oxygen there. And then we have an R group. Okay, we have an R group. Okay. The R group is very unique to each amino acid. So the amino acids are going to consist of these four groups attached to that alpha carbon. How they're going to vary in function and structure is the uniqueness of the R group. Okay? And amino acids are often broken down into further kind of categories. Okay, so let's go through those real quick. We have the non-polar, okay, what we call the hydrophobic, okay, R groups. Okay, so some amino acids are non-polar R groups. Okay, these are hydrophobic. Think of them as like water-fearing groups. Example of these are proline, tryptophan, phenylalanine is one of those, or valine. Okay, so non-polar hydrophobic groups. Okay, another group could be the non or the polar. Okay, so these are hydrophilic. Okay, hydrophilic, water-loving R groups. Okay, so think of these as water-soluble. Okay, now these polar hydrophilic R groups, these can be subcategorized into being neutral. They might be basic, or they could be acidic. Okay, so the polar hydrophilic R groups, these amino acids are further subcategorized into the neutrality, basicity, and acidity properties of that R group. Okay, so we might see glutamate as an acidic hydrophilic R group. Okay, we might see something like lysine. Lysine is in the basic hydrophilic grouping. Or we might have something like serine or tyrosine, which are in the neutral hydrophilic R groups. Okay, so amino acids Building blocks of proteins, so important to the body and sustaining life. Okay, they're going to have 4 groups: the ammonium group, hydrogen group, carboxylate group, and then the uniqueness of their R group, which will further categorize them into being a non-polar hydrophobic or a polar hydrophilic R group, and could be neutral, basic, or acidic.